Yo, maurieo! Land Survey 1, 2017 Traversing Test Review. Hi. Alright, in this video I'm going to take a look at the traversing test. I've just completed marking it, and now would be an opportune time just to comment on some of the things I found or that came out of my marking, and some of the small little errors and things that people made that you need to perhaps look out, because there will be similar questions to this in the upcoming national exam at the end of the semester. So let's just take a look at the. Let's get the test up on the big screen, and we'll take a look at it there. So here was the test here. Held on the 31st of May. The test is similar for both the Bachelor of Engineering Technology and the New Zealand Diploma of Engineering. It's a basic test on traversing, so there's no reason to diverge into more complex material for the Bachelor of Engineering Technology students. So let's have a look at the first, and perhaps we'll leave that as such. So as a general rule, this question was quite well done, provided that people were careful and they moved through it and got the bearings right. There was a couple of little tricky businesses. First up, this one here, where you can see where you're adding in the clockwise direction. So that one, the 145 was added. Some people subtracted that. It should have been added. So 108.24, you must have the bearing going away from you. So 288.24 there, and then add the 145. And you can't quite see the plus sign there, but it is definitely add. So when you add that, 433.52.30. 433.52.30, you say. That can't be a bearing. No, it can't be. That's correct. So you must take off the 360 degrees. You've gone past 360 to give you the bearing of 73.52.30, which is the bearing from OIT going this way. So that's looking good. Remember, these diagrams are drawn to scale to help you. So if you're getting like some people subtracted along there and got a bearing of 144 degrees or something like that, impossible, because north's up there, 90's out here. It cannot be 144 degrees. So, use your noggin. And that, as I said, they are to scale and to usually. So you've got to think about it a bit. All right, so 73.52.30. We're now underway. Coming back down this way, of course, is 253.52.30. Can't be possible. So we set that. Remember, we must set the legs of the legs of the angle going away from you. Now, once again, this one here is going anti-clockwise. So that one is subtracted. That's subtracted. So we've got 253.52.30 minus 128.30. 120 is 125.21.10. And once again, we can see that 125. That's quite sensible. Going down there, 90 would be out there, 125. All right, so we come down to peg 2 now. The 125 going away, of course, would be plus 180, which is 305. And again, we're subtracting because we're going anti-clockwise. Anti-clockwise is subtract. Minus 116.17.30 gives us 189.03.40. 189, yeah, that looks pretty good. 180 straight down the page. 189.03.30. So, take 180 away from that. Well, that's pretty easy, isn't it? 903.40. Now 90340, so that's going away up there, and you're going to subtract. Now you can see there that you're going anti-clockwise, so you're going to subtract. If that's 9 there, you're going to come back to 0 or 360 there and go past. So and we've got to take away 87, 28, 20. So that's going to give a negative number. Now some people continued on with the negative number, which is you've got to take them away from 360, and the negative number means take it away from 360. Or you can add the 360 on there to start with, which is what I did. So I, instead of going with 9, I went 369. It's no problem. It's just not a bearing when it's like that. So as long as you tidy it up at the end, it's not a problem. So take away 87, 29, 20, you get 281, 34, 20. Let's have a look at that. Yeah, well, 270 is out here. Fine, no problem. And yeah, that seems good. So yeah, we'll go with that. So now we get round to the next one. And 281, obviously we want it going away. Well, that's going to be 101, 100, 281. 101, 34, 20. However, again, we're going negative, and again, we're going past the 360. So we've got to add 360 on. So instead of 101, add 360, it's 461. Then take your 149, 17, 30 away, and you get 312, 16, 15. Which is, yeah, that's looking right. 270 out there, 360. It's somewhere between 270 and 360. So all's good. All looks good. 312, of course, when we get to OITMM. Now, some people didn't even use this last angle in their calculation. So they got through to here and just used that. So they had nothing to really close on. I don't quite know. No, it was weird how that worked out, but you must use all the angles in a nice and methodical sort of way. So 312, and we're at MM. We want going the other way. Take 180 up. 132, 1650. All looks good. This is going clockwise, so you've got that going away there, and clockwise around there. You're just moving the angle round to there. 246. 58, 40 you get. 246, 58, 40. No, that's nothing like 246, 57, 50. No, it's about 50 seconds too much. So we've got to subtract 50 seconds from that. Okay, so that to make it 246, 57, 50, our published bearing, which we know to be true. So we've got to put a little bit of adjustment back through that. Now, just note that it's negative. A big mistake that people made was they worked out it was negative and then just added the adjustment. I don't know why. So you've got to just be careful and slow and methodical. Think about what you're doing, because that just, just stuffed up everything from there on for them, and yeah, create big problems. All right. So the bearing must close is 50 seconds. We have got 6 setups. 1, 2, 3, 4, 5, 6. So that's 6 angles. 1, 2, 3, 4, 5, 6 that we've measured. So that's what we adjust the angles, but the adjustments are done to the bearings. Okay, 6 of them. The same as 2016 and possibly even 2015. Not 7, not 8, 6. Okay, now 6 goes into 50 8 times. It's not 8 into 50 6 times. 50 divided by 6 goes into 8. 6 8s are 48, and there would be 2 left over, 2 remainder. So what that means is that you're going to add those 2 to 2 out of the 6 things. So I've got a adjustment scheme there where I'm going to have 8, 8, 9, 8, 8, 9. So I've got 4 of them, it'll be 8, and 2 of them, which will be 9. So That's my scheme. So then I'm going to go 8, and 8 is 16, and 9 is 25, and 8 is 33, and 8 is 41, and 9 is 50, and that all works out. That's my cumulative adjustment. Then I add these across here, like so, like that, and then I round them to the nearest 10 seconds. And these are the marks allocated. All right. Now, with these problems, generally the misclose is going to be, well, it's usually around a minute. 8 seconds per station's good. 20 seconds per station's getting on the rough side. So a minute to 2 minutes max. Except that one year, I think last year or the year before, I made a mistake and it ended up as 10 minutes 30 instead of 30 seconds. But everyone adjusted it out and it was all worked out all right. I never admitted the mistake until now. But generally it's there. So if you're getting something like 8 degrees, you've got it wrong. You're wasting your time trying to adjust that out. It's just wrong. And it shows that you don't actually understand the concept that you're dealing with here. So they will be small in the area of 1 to 2 minutes, at least under 10. If they're any more than 10, something's not quite right. So you need to go back and check and double check, make sure you've got it right. So yeah, that's question 1. Generally well done. Generally pretty well done, I have to say. Okay. Now, question 2, the traversing question. Well, pretty much really a no-brainer. This one, it's pretty. It should be an automatic thing. So we multiply the cosine of the bearing times the distance will give us the north, the delta north, and the sine of the bearing times the distance, the delta east. So work those out right, and then add them up. And that's the correction. That's the correction. Now, again, these should be small corrections too. Maybe, at worst, no more than 0.1 in this type of one here with only 4 legs over a very short distance. There's no, it's just there. So if you're getting big differences like a meter or, even 0.2 of a meter, go through and check your run out, your ordinates here. And, as soon as I see this question when I'm marking, I go and look here and here, because that number and that number should be the same. That's the whole point of the exercise, is that they should be the same. So that's the first thing I look for, are those two correct? Yeah, they're the same. So that means something. If they're different, well, I know it's wrong straight off. I can tell straight away. There's no qualms about it. So yeah, these should add up here, and then you apply the correction. And again, make sure that you actually get that number. A lot of people applied the correction the wrong way or got a different number there. I mean, it shows a lack of understanding of the concept. And the concept is that the point you start at should be the point you finish at. That's why we're actually doing the adjustment, is to get it there like that. So that's that review of that, the coordinates. So do that nice and carefully. Then we're going to look at the misclose. So we get the total here, the total distance, which you can get by Pythagoras, and then 567.47 divided by 0.04, round about 15,000. If you do it to 3 decimal places, you'll get slightly different numbers, but generally in that order, somewhere between 12 and 20,000 is acceptable. Over here for the tan to the negative 1 of 3 divided by 2, which is 1.5, gives this angle here is 56 degrees 19. So we can see here we've gone minus 02, minus 03. So that's the angle out there. We've worked out that angle there is 56.19, and it's clockwise from north. So we add 180 236.19 for 0.04, 1 to 15,000. Okay, now this brings us to question 3, the missing line. Now there's a number of people that got 98.33%, I think, in the exam. And the only reason they got that is because they didn't read this question properly. Okay, they says here, calculate the missing line from peg 1 to peg 2. From peg 1, so you're going to start at peg 1 and finish at peg 2. Not start at peg 2 and go to peg 1, at 1 to 2. Now that's not going to affect the distance, but it only affects the bearing. So I wanted the bearing from 1 to 2. So read the question, find out what the client wants. Write your appropriately rounded answer, okay, in an appropriate location on the diagram, which is here. Now, a lot of people did not write their rounded answer on the diagram. They did not write their rounded answer on the diagram. Half a mark off. They missed their opportunity to get the 100%. You must pay attention to detail. You must read the question. All right. So peg 1 to ITMB. These are all done as radiations from the mark out. So straight away, you should know that you're going to have to reverse that. 1460430, 12.824. This one 245, 5540, 84797, and then 337, 5230, 27238. Write them in, add them up, and then convert them to a bearing and distance. That squared plus that squared equals that squared. And again, this is 256. Work out the bearing. So it would be tan to the negative 1, because the negative 1 would be down here. So it would be this angle here. Tan to the negative 1, 80.524. Sorry, yeah, 80.524 divided by 19.997. And that would give you an angle, I would say, this angle in here of 56.0312, and, oh, sorry, 76.0312. That's, yeah, better, 76.0312. And then you must add 180, 236.0312. If you're unsure, run it out. Cosine of that times that should equal that. Sine of that times that should equal that. Simple. Now this last question was probably the question that was best done out of all of them. It's fairly straightforward. The horizontal distance. If you don't know whether it's sine or cosine, if you put the cosine in there, you're going to get an answer like 8.5 or something. Now the distance, when you measure the slope distance, it doesn't change the distance that much. So whether you put cosine or sine in there, if you put cosine in there, you're going to get a ridiculous answer, which won't be true. So you put sine in and you get an answer that's less than that, from slope to horizontal. Simple. So if that one's sine, this one's going to be cosine. So, and it's fairly straightforward. You just start at the ground level, up the height of instrument, whatever the slope distance is, and in this case here, because it's 93, it's going to be a negative slope distance. If you go 63.389 times cosine of that, you'll get a negative number, and then you take off the height of the pole, and you should get 94.5. It's simple as. And a predictable question. There's no excuses really for getting this one wrong. If you got this one wrong, you just did not learn how to do it. You did not take the time to understand how it works. This is just a bonus. This is just a giveaway 5 marks for minimal effort. So You do need to spend some time, work out how to understand it. The question is the same as 2016. No reason for getting this one wrong. No excuses. You just didn't do enough work. So yeah, so that's my review of the test. Yeah, that's my review of the test. You'll notice in some times there I've been a little bit brutal about some of these things, but to be honest, it was a very predictable test. You were given a lot of time. You have a lot of examples to work through. There's just no reason for not getting these correct. The only excuse you can have is sometimes on the day you get a few of these these sort of things mucked up, or you push a few buttons wrong. But there's plenty of time to do the test, and if you're understanding the concepts that are involved here, you should have no reason whatsoever. You should be able to go back and recheck things until you get it right. So a good anything north of 80 is reasonable. Anything south of 80, you just didn't do enough work, just didn't do enough preparation. There's no other reason for it. It's just these sort of calculations, you've just got to keep doing them till you understand them. They're bread and butter for surveying. It's what you're doing day in, day out, and you do need to have a good understanding of it. So hopefully this will, for those of you that have found a few problems, it'll be a bit of a wake-up call for the exam. You need to put the time and effort in. You need to know how to do these. You've got plenty of examples to work on, and you know where I am. You can find me anytime. Well, you can arrange to find me anytime, and we can get these questions sorted. So yeah, all good. Cheers. See you.